Hello and welcome to my channel Physics for Students, and welcome to the third video in a series of videos which you are learning about interview questions or questions to science and mathematics graduates. If you have not watched my first and second videos, I have put it on the I button. Please go ahead and watch those videos because it is a series and it is building up upon one and another video. Now, in today's video, we are coming with another kind of out of the box and a weird question. But as I told in the beginning of the video, the objective is not the question, but how much you can think and how much you know about physics and mathematics. Right on the screen, you can see if you could eliminate one equation from mathematics, which would it be and why? I know it is a very weird question, but you see there are two questions. Which equation you would eliminate and why would you eliminate? Now this question actually carries a profound, deep understanding. First of all, you need to understand that why the recruiter is asking a question which is to eliminate rather than to include or add. Now, the basic idea is that when do you eliminate things? When do you throw away things? For example, your dress or anything. When do you throw away? When there is either there is too much, there is an abundance of things which you really don't need, or it is redundant, it is not useful. I mean to say, most of the time we see, okay, we have got something new, we need to throw it away. So the question is on a negative front. First of all, if you say, okay, this equation, say for example, equal to mc squared, then the recruiter is going to ask why. That means you are subtly falling in a kind of a loop. If you say this, you have to justify that. That means this question requires a very deep logical thinking. First of all, let us see why the recruiter is asking. Now, here it is on your screen. The recruiter is asking this question to test the candidate's critical thinking creativity and ability to engage with abstract or unconventional problems. It is a thought experiment meant to see how the candidate evaluates mathematical concepts, their importance and their practical impact. Remember, the moment you are saying that this equation needs to be eliminated, you have to also think that what is going to impact, what is going to change on the level of physics and mathematics. So the most important thing is critical thinking, and you have to go a kind of abstract thinking, which is a thought experiment. So objective is, number one, prioritization of skills. Remember, whenever you are eliminating an equation, whether it is very important or not, if it is important, you cannot. Second is knowledge depth, problem solving, and the perspective. That means, what is the perspective you have? The mistakes, the chances of mistakes are huge. Number one, you can choose a very fundamental equation, which I just told you, equal to mc squared, and you made a mistake. You do not have the justification. You have already told this, but there is a contradiction and you have indifference. So this particular question, that which equation you would eliminate, it is very difficult. Again, what I would like to tell you before I show you the sample answers is that you can also put your comment telling that I also feel in this way, this equation can be eliminated. I can put it up in the later video as a suggestion. Yeah, obviously the suggestion has to be something constructive. Let us see. Number one, the question answer is that I would eliminate geocentric equations used to model planetary motion in ancient times. Why? Because it might be a kind of a hindrance accepting heliocentric and modern cosmological models. Now, this also has a problem because based on the geocentric equations of the Kepler and Galileo and others actually developed. But however, what it is telling is that this geocentric equation is already done. The world, the physics, the mathematics have moved ahead. So why do we stick to that? Again, as we are telling that if you have got that, button type of phone today, and you are working with an Apple or an iPhone or a smartphone, would you keep that? Now, you might keep that as a memory, but does it have any usage? No. So you eliminate that. So the geocentric equations, again, the answer, remember, it is not a particular equation. The answer is something very deep. The answer is that whether the recruiter can see that you are not eliminating something important and which has a direct impact in today's world. You are eliminating an age-old equation. Geocentric equation where we have moved ahead. Sample answer number 2, I would consider eliminating the Navier-Stokes equation in fluid dynamics, not because they are not important. You see how it is written. Not because they are not important, but because solving their problems exactly has proven so elusive. Removing them might force us to rethink fluid dynamics in a simpler, effective approach. So Navier-Stokes equation definitely is a very important equation, but why are you saying to remove Navier-Stokes equation? Now, you might argue with me, but the point is that it is solving their problem has been so elusive, people really don't understand, and it has not got to anything. We have not got to a proper conclusion. Redundant, which has not got a direct implication to practical life, I am eliminating. So I am eliminating and I am telling the reason. Number 3, I would eliminate any. Now you see, as I told you, every answer in this series of videos are something one, and the second and the third. The first one is concrete, second word is little bit, is this one. I would eliminate any overly redundant equation, as mathematics thrives on simplicity and elegance. By removing redundancies, we can make the field more streamlined and intuitive for learners and practitioners. Now you're making a generic statement that I would remove anything which is very redundant, because mathematics is something which is dependent on simplicity. And so here are a few points which you should remember. Number 1 is that state the equation you would eliminate. Steps. Number 1, explain its role in mathematics. That is, has got no role, it is redundant, it is elusive. Third is that justify that with a thought and explanation, and conclude by mentioning the potential impact of its removal. That means what will happen. Now, if you want to remove f equals to ma, or if you want to remove any second order differential equation, it would create an immediate impact, which you cannot do. So the first one was a geocentric equation, which we have moved ahead. Second is Navier-Stokes equation, which is very elusive and we have not seen much of a result on that. And third is that any overly redundant equation, because mathematics thrives on simplicity and elegance. Navier-Stokes equation, because it is elusive. In this way, can you justify? Because without justification, you will fail. And it reflects your understanding of mathematics' interconnected nature. That means if a particular equation is somehow related to another, so a change of little bit here would cause a change of little bit there. That is not done. So if it would have been causing a change in the interconnected nature, then you should have told that it is not interconnected. So it hardly matters if you remove that. So the most important part of this type of a question is that what you eliminate, why you eliminate, the strong sense of justification, the strong sense of prioritization, because you cannot take any equation, and most importantly that whether you actually justify that, show the impact, and it has got no interconnectedness, that another part of mathematics is being impacted. So this is a very tricky, different kind of a question. I hope that you liked it. Watch out for the second question in this. So the second question again is a little bit tricky, a little bit something you won't find it daily. Right on the screen, imagine you're shrunk to the size of an atom. What changes would you experience in your surroundings? Now, I know that you might be laughing while watching this video or going into this kind of a lesson. Now, first of all, as I told you, that why the recruiter is asking the question, it is not that you will be shrunk, honey, I shrunk the kids, or you will go as an atom, but there is a very deep meaning, there's a deep sense of on the size of an atom, what is going to happen? You are reducing everything into the quantum level. So the entire perspective of space and time, which you see, feel, touch, etc., is not going to be there. So point number 1 is that the recruiter wants to judge that whether you have that imagination or not. Second thing is that it asks what changes would you experience. That means the moment I move from a macroscopic to the microscopic world, there will be certain basic changes in terms of physics. There should be certain changes in physics which are, it's very evident. You need to explain that evident. Now, the recruiter's motto is not to go that you really imagine and then you start thinking about quantum field theories and Lagrangian mechanics. No. The basic idea is that from the macroscopic level, if you go to the microscopic level, what are the basic changes which happens? Are you aware about that changes? And if you are aware, tell it. So, the recruiter is asking this question again for your imagination, problem solving. And I was watching a wonderful video of Brian Greene on special theory of relativity, and he starts the video telling that whatever we see over here is a kind of a scale. The blood vessels, the cosmology, the real world, the people, kilometers, etc. And how do we change the scale when we move fast to the speed of light? So it is a question and a perspective of changing the scale. And the recruiter wants to know, or the principal wants to know, that are you aware about that scale change? Not talk anything nonsense. So objective again is acknowledging the new scale, addressing change in perception, also referring the scientific concepts. So first is that I know what is the scale that is being changed. Once the scale is changed, can I address the changes in perception? That is my view, my touch, my feeling, etc. And referencing scientific concepts. That means in case you are given a job where it requires a lot of thinking, abstract thinking which will take you beyond the territory of the normal scale that you're doing. Are you aware about that? Can you do that? Now you see that Einstein has done that in the Gedanken, the famous elevator experiment. So the recruiter, before recruiting you, wants to see that how far you can push your level of thinking, imagination. So it is not a question of atom or quantum mechanics, the amount of imagination you do. Let us see the some sample answers. If I were shrunk to the size of an atom, I am not reading, just read the important parts. That my surroundings would no longer appear smooth, but it would be constantly vibrating molecules and empty space. So you're not in this world, you're in a world where the quantum fluctuation starts happening. So it is constantly vibrating. Now next is that my perceptions with light would change too. Yes, why? Because my size would be smaller than the wavelength. Again, see, a perspective difference. Wonderful. Because already the sensory inputs are changing from a deterministic world to a probabilistic world. These are the key things that the person wants to see within you, that whether you have the perception of moving from a constant smooth space to a vibrating area or world of atoms and molecules. You cannot see light because you are reduced to the size where the wavelength won't be perceptive to your eyes. And third, that everything will be interactive to forces and not in a deterministic way, but in a probabilistic way. So you are already telling about quantum mechanics, probability, Heisenberg's uncertainty principle, but you are imagining that. It might happen that your research or your theoretical physics work in cosmology or quantum field theory might need you to push to that level. So that is the question. Sample answer number 2 would be, as an atom-sized being, I would experience surrounding fundamentally unpredictable. That means you are already stating again the Heisenberg principle, uncertainty principle. Chemical bonds would feel like tangible connections, etc. because chemical bonds would start reacting. Even basic concept like up and down might lose meaning because gravity is almost irrelevant in that scale. As I told you, that perception, scale, there won't be an up and down and a left or a right. So this is again important. Let us see what are the key takeaways. The first key takeaway is that it shows the ability to think critically about the changes in perception. Again, perception and interaction with the surroundings. Second is that it reflects logical reasoning about how electromagnetic forces and quantum principles would influence the experience in such a scenario. Obviously, because until you reach up to that perception, how you can imagine and how you can tell that these things have got a logical outcome also, that electromagnetic force. And finally, demonstrates an understanding of quantum behavior using the terms like probabilities and vibrations, showing that the atomic sized world differs from our perception. That means the recruiter is again expecting that you know these terms. and you express those, what will happen if you are shrunk to the size of a neutron or a proton? Then what are you going to do? You will get puzzled. But remember, the moment you are moving to the quantum level, you need to pick up those uncertainties, you need to feel those probabilities, you cannot see light as it is, you are going to feel the vibrations of the chemical bonds, etc. The more you do, the more you push, the better will be your understanding of physics and mathematics in the career, which might be into research and equation from mathematics, which one it would be and why. So there were two questions in one, and imagine yourself to be shrunk to that part. So the first part was a very good profound knowledge of the equations of physics and mathematics. The second is basically about quantum mechanics, but it is not typically the mathematics of quantum mechanics, but visualization up to that level. So watch out for a few more videos which are coming up. These would again be a little bit more mathematical and something very deep in understanding of physics and mathematics. So please do subscribe to my channel Physics for Students and let me know how this series is going, and you can also put up your suggestions. So see you in the next video, but till then, may the good Lord be with you.